This is part 2 of the Algebra 1 Statistics Study Guide. We've already talked about some box and whisker plots, talked about mean absolute deviation, variance, standard deviation, started to delve into z-scores. Z-scores are the number of standard deviations away from the average something is. So we're talking about z-score, the formula is x minus mu all over sigma. The more z-scores you are away, the less likely something is to happen. This is where we start to talk about the bell curve a little bit and how likely something is to occur. Questions 9, 10, some of the rest are all z-score related. So it's really talking about the likelihood of something happening. Again, at the average, at the mean, right in the middle, it has the highest chance of happening. But as we get further out, 1 standard deviation away, 2 standard deviations away, the likelihood gets smaller and smaller. So that makes you more and more rare, and it goes on the opposite side also, makes you more and more rare. So that's what z-scores kind of talks about. Question number 9, the average height, the mean height for U.S. males is 70 inches with a standard deviation of 2.8. The mean length of a cat is 18 inches with a standard deviation of 1.2. Mr. Jones is, I'm assuming that's a human, is 66 inches tall, and his cat, Mr. Tinkles, is 16 inches long. Who is shorter compared to average height for the respective species? Explain your answer. We have to break this down. Height for male, 70 inches, standard deviation of 2.8. Mr. Jones, 66. Let's talk about the cat. 18 inches, standard deviation of 1.2. The cat is 16. Now they're both below average, but let's talk about who's below average more based on how many z-scores away, how further away from the average they are. Let's talk about Mr. Jones. Z equals x minus mu all over sigma. So that is the x, which is the element for Mr. Jones, is 66 minus the average, which we know is 70, all over the standard deviation, which is 2.8. This works out to be -4 divided by 2.8, which is a -1. Let's say 43. So pretty far below down, not super down there, but definitely below the average. Let's talk about Mr. Tinkles. It's again x minus mu all over sigma, that's the z-score. Plugging in x as our element, which is 16 inches, minus the average, which is 18, over standard deviation, which is 1.2. So this is -2 over 1.2. -2 divided by 1.2. -1.6 repeated. So you might say, well, this is -1.3 is larger than that, but since this is negative, it's further down on the bell curve. We drew a picture. This is -1. This is my average. This is -1. -1.43 is here. -1.6 is there. Since that's further away, -1.6, Mr. Tinkles is shorter relative to his species. Moving on to question number 10, it says the data set shown has an average of 64.5, so my mu is 65.4, and a standard deviation, a sigma of 26.7, rounded to the nearest 10. How many of these data points have a z-score greater than 0.4? Now what I could certainly do is I could take each of these points and plug them into the formula. Z equals x minus mu all over sigma, and I could plug in, let's start with 32 minus the average, which is 65.4, all over the standard deviation, 26.7. Calculate this, 32 minus 65.4 equals -33.4 divided by 26.7, which is a -33.4 divided by 26.7, which is a -1.25. That's certainly not larger than 0.4. -1.25 is smaller than -1.4. So it's not 32. But that's going to take a long time to do all of that. So instead, what I really should do is think of it like this. I want a z-score that's greater than 0.4. So let's find -0.4. Let's find what element, again, let's find what element, when I plug in -65.4, divided by 26.7. What element would give us a z-score of negative 0.4? Once I find that, and I know what element gives us that, I'll look for numbers that are bigger than that element. Again, if this is the element, this x, gives us a z-score of negative 0.4, we'll look for x's that are greater than whatever number it gets. So let's actually solve this. Solve this, times 26.7, times 26.7. That canceled. On the right-hand side, I have x minus 65.4. On the left-hand side, I have 26.7 times negative 0.4, which is negative 10.68. Solve by add 65.4, 65.4, add to both sides. X equals plus 65.4. Looks like 54.72. So when I plug in 54.72, that would give me a z-score of negative 0.4. Again, to recap, what I did was I plugged everything in looking for the x that would give me a z-score of exactly negative 0.4. 54.72, if this I plugged into the z-score formula, that would give me a z-score of negative 0.4. Now we're looking for things bigger than negative 0.4, so let's choose elements that are bigger than 54.72. Which would be this one, this one, this one, this one, this one, and this one. Those are the 5 that would give us a z-score of greater than negative 0.4. Again, you could plug in all of them, but that would be 12 different numbers to plug in to find the z-score for each of them. It's a lot of work unless you stop and work smarter, not harder. Question number 11. A data set has a mean of 52.34 and a standard deviation of 6.35. An element in this data set is 41. What's the z-score? This is a very straightforward question. Z equals x minus mu all over sigma. So it's asking what is the z-score if the element is 41 minus the average 52.34 and the standard deviation 6.35. Very straightforward, very easy question. We do this work. 41 minus 52.34 is negative 11.34. Divide that by 6.35, and we get negative 1.7, let's say rounded to 1.79, negative 1.79. Makes sense that it's negative because it's below the average. Number 12, a data set is a mean of 24.7, standard deviation is 8.93. An element set is 1.3 standard deviations above. What's the value? Now this is different than this one. This one right here gives us the element, and it's looking for the z-score. This one says it's 1.3 standard deviations. That is not the x. This is the z-score. Number of standard deviations away is the z-score. We still use z-score, x minus mu, all over sigma. The difference is the z is 1.3. This is above, so it's positive. If it said below, it'd be negative. X is what we're looking for, minus the average, 24.7 over the standard deviation, 8.93. We're going to have to solve this guy. Multiply by 8.93, multiply by 8.93. On the right-hand side, we have x minus 24.7. On the left-hand side, we do 8.93 times 1.3, which is 11.609. Add 24.7, add 24.7. We get 36.309 equals my x, 36.309. Doesn't say to round, so we'll leave us 36.309. Question number 13. Table shows the scores of an algebra test for 4 different classes. Also shows the z-score of the students. Which had the highest actual score on the test? So I have these 4 individuals, Bob, Morris, Kathy, and Robin, and I got to do for each of them, we'll start with Bob. I know that the average for his class, I know the standard deviation for the class, which of course is sigma, that's mu, and the student's z-score. So they give me the z-score, They give me my mu, and they give me my standard deviation, which means they're obviously looking for x. So my x, sorry, start over. I'm not going to rewrite the equation. I was going to rewrite the equation. Let's just do z equals x minus mu all over sigma. The z we know is 1.3 equals x, which is what we're looking for, minus the average, which in Bob's case is 82, divided by the standard deviation, 10. Going to solve this equation, times 10, times 10. This is 13 equals x minus 82. Add 82, add 82, x equals 95. So for Bob, he got a 95. We're going to do the same thing for the rest of them. Morris, so 1.1, which is the z-score, equals x minus the average, which is 88, or the standard deviation, which is 9. Multiply each side by 9 to get rid of that. 9.9 equals x minus 88. Add 88, add 88. X equals, 88 plus a 9.9, we should be rounding up a 97.9. So pretty good, 97.9. As of right now, Morris is the highest. Let's start to do Kathy. 1.4 equals x minus 84 over the standard deviation, which is 11. Multiply both sides by 11 times 11. X minus 84 equals 15.4 plus 84 plus 84. And like I was thinking, that was a 99.4. So now, Kathy is the highest. I find it unlikely that Rob is going to be much higher than this because she starts with a very low number. The standard deviation is 6, which is the lowest one. The highest z-score, however, in terms of actual score, I don't think this is going to be enough to get that all out past the 99. But we'll do it anyway. 1.8 equals x minus the average, which is a 79. All over 6. Times 6 times 6, x minus 79 equals 10.8 plus 79 plus 79, and we get 89.8 equals x. I showed all of my work. Who had the highest score? Kathy did with a 99.4. Notice that all my work is shown. Here's what you ought to do if you see this question on the test. Number 14. From 1984 to 1995, the winning scores for a golf tournament were as follows. Find the average and standard deviation for the data, round to the nearest hundredth. I am not going to put them all and do all that work. So what I'm going to do is use my trusty calculator. And I'm going to plug all of these in. If you remember, you hit stat, like the stat button. Then I'll hit edit, so I can hit the number 1, or I can hit enter, because it's already on number 1. And I'll put all these numbers in my list. If you already have things in here, let's say there's a bunch of numbers already in here, and you need to clear them out, please don't hit the delete button. I mean, that might clear one, but if you go up to the top and hit delete, you're going to delete your entire list 1, and we're not going to be able to help you get it back. If you want to clear out this list, hit the clear button, and go down, and it should be all cleared out. So let me put all of these numbers into my calculator very quickly. One thing to check is to make sure you put them all in there. You might have to double check them, but I know there's 12 because this is L12, which means there's 12 in here. I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it seems like I got them all. A is just to find the mean and standard deviation. I can do that by hitting stat, calc, move over by hitting this button. From there, move over by hitting this button. Go to calc, I'm going to do my one variable stats, enter, enter. I have my x bar or my average. So that's my mu, or my x bar, equals 278.583 repeating. That's just around to the nearest hundredth, so I'm going to listen to instructions, 5.8. And the standard deviation is 3.01. 3.01 for my standard deviation. B is to find the z-score for the first 4 unique scores in the list. So I'm going to find the z-score for each of those 4 by using this information. We know that the z-score equals x minus mu all over sigma. So the z-score for the first one is 276 minus 278.58, all divided by 3.01. We can put this in your calculator if you're careful with how you do it. And you put in parentheses 276 minus 278.58, close the parentheses, divide that by 3.01. So I got the first one. I'll do the same thing for the second one. So same idea, except I put 279 here, in parentheses 279 minus 278.58, close the parentheses, divided by 3.01. There's my second one. Might as well write them down before I lose them. This first one is negative 0.857. The second one was 1.3, oh, sorry, 0.13, 0.1. Since the 5 rounds the 9 up, I'm going to make this a 4, 0. Let's do the same thing for the next one, which is 277. Open parentheses 277 minus 278.58, close parentheses, divided by 3.01. Now I have negative 5.25, negative 0.525. And the last one is 278. So open parentheses 278 minus 278.58, it's going to be a very small number, divided by 3.01, negative 0.193. Negative 0.193. How many of these winning scores fall within one standard deviation of the mean? Once again, to find within one standard deviation of the mean, I know that my average is 278.53. So the question is, what is one standard deviation that way and one standard deviation subtracted? So not just subtracting, adding one, I'm really adding one, which is a 3.01. So adding 3.01 to 278.53 plus a 3.01 is a 2. Sorry, this guy froze a little bit. It's a 281.54. Thanks for bearing with me. And if I subtract, take 278.53, sorry, 58. That's why I want to make sure this is right. This is 59. Subtract 3.01 from 278.58. 58 is a 278.57, or 275, excuse me, so 275.57. So we don't know how many fall within 275 and 281. Yup. 280, yep, still within there. 282, nope. 279, yes. 285, no. 272, too low. 279, yep. 278, yep. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. That one was not. So 9 of them fall within one standard deviation of either side. One standard deviation means plus 1 and minus 1 on either side. All the rest are either bigger than 281 or smaller than 275. And the last question, the math class took a test. The result yielded an average of 89, a mu of 89, and a standard deviation of sigma of 4. If the students have a z-score less than -2, not equal to -2, less than -2, in other words, -3 or -4, those are less than -2, then they have to do a retake. Use the table below to determine which students have to do a retake. So let's see the z-score for each of them. Z-score equals x minus mu all over sigma. The z-score equals x, which is the element. In this case, it was a 77 for Andrea, minus the mean, which is an 89, over the standard deviation, which is 4. This is a -12 over 4, which is a -3. -3, yes, a retake. Nora, 83 minus 89 all over 4, which is a negative 6 over 4, which is a negative 1.5. Negative 1.5, no. Rosella, 84 minus an 89 divided by 4, which is negative 5 divided by 4, which is a negative 1.25. Negative 1.25, no. Donna, 80 minus an 89 divided by 4, which is a negative 9 divided by 4, which is a negative 2.25. Negative 2.25. Yes. Nicole, 81 minus 89 divided by 4, which is a negative 8 divided by 4, which is a negative 2. Negative 2. It says less than negative 2, that's equal to negative 2. No. And then Emily. Emily got a 91. Do you really think she got a z-score that's negative enough to do a retake? 91 is above the average. So I know it's going to be a no, but let's do it anyway. 91 minus an 89 divided by 4, which is a positive 2 over 4, or 0.5. Because it said to do it, 0.5. This is definitely a no. She does not need to do a retake.